Okay, we have the LEDs on at 24 volts that we programmed, as you can see there. We have the voltage set at 24 volts and pulling about 400 milliamps. We're using MPLAB to code. So there's a working CIGCOM module. Okay, this is testing the analog circuit, and what we have is resistors hooked up. That's going to be also potentiometer is what we're using, but for right now, to make sure we have the values coming out correctly, we're using a 250 ohm resistor, which we see here. Now we're going to go ahead and turn the voltage on to the entire circuit, which is 24 volts, but we also have a 5 volt input going into what's going to be the sensor. Now if we take a measurement of the power at this pin, we're going to go ahead and see that it's 2.3 volts, which is what it should be when you have a 250 ohm resistor. So measuring the different resistances through that gives us the full value of the 4 to 20 milliamp sensor inputs. Okay, here we have the full circuit, and we're going to go ahead and show that we can use the analog and the digital circuits and the RTDs all at the same time. So when we hook the power up, we have 24 volts going to the circuit, but we also have a 5 volt power to the sensor that we're using. So right there you can see that we're pulling about 380 milliamps, and what we're showing here is that all the LEDs are on, if you can see it from the glare. So all the LEDs are on, and then we also have a sensor hooked up into this port, which is actually the 11th sensor, and then if we measure the voltage across that, we get 2.3 volts because we're using a 250 ohm resistor. Now if we go ahead and turn the power off and replace this 250 ohm resistor with another one in series so that we're getting a total of 500 ohms, then we can see that the voltage output is going to be 2.5 volts, I believe. So with that calculation, we have our basically 250 ohms in right here that we have for our actual circuit, and then we have another 500 right here. So you have to add all of those up and then divide them by the 5 volt input of the sensor, and then once you get that, you can do a conversion equation and figure out the voltage that's going to come out correctly of this pin and out of the op amp that each one of these circuits has, an operational amplifier, to give you the correct voltage out. And so when we turn the voltage back on, we see that we're still at 24 volts, pulling about 380, 390 milliamps. All the LEDs are on, as you can see, and when we measure the voltage on this analog input sensor right there, the operational amplifier and the port are going to read 2.5 volts. So that is a demonstration of both the analog and the digital circuit working.